Hello everyone, welcome to Arcteq Webinar Wednesday. Today's topic is AQ1000 Arc Quenching device, installation guidelines, testing and commissioning. My name is Mikko Manninen, Product Manager for Arc Flash products. Welcome. First, a few reminder for the low voltage arc, some typical applications, and then later on we will do some testing with the arc quenching device, and we can also have a look about the oscillographs, about timing test and so on. And I will also tell you about few words about what type of test equipment can be used, what kind of camera flash and multimeters, etc. So let's move on. Low voltage arc typical application. Low voltage, high current. Low voltage panels are very often underestimated. There can be extremely high amount of current. If the arc can ignite, the current will hold and it will hold the arc flash as long as there is energy to feed the fault. Trend is to build higher current boards, quite typical 32 kiloamps to 65 kiloamps boards. Today even lower level kiloamp boards are being built, but the trend seems to be that even higher, up to 100 kiloamps and even more short circuit capability boards have been built. A couple of real life examples from two sites. Forgotten tool above circuit breaker. This happens a few years ago. Electrician left the tool when he was tightening to correct torque. He was tightening the bus bars on top of the circuit breaker, and he forgot the tool on top of the bus bars, but it was not exactly on top of the bus bars. There was some kind of cell, and the tool was on top of that. When the circuit breaker was closed first time, the circuit breaker shaked a little bit, and the tool dropped down on top of the bus bars, like this. And then there was an arc flash, and luckily there was also arc flash protection, and you can actually still use the tool. Another example, another site a couple of years back was the withdrawable starter, very high quality switchboard, very high ratings. Transformer was very close to the low voltage board itself. And when electrician took the withdrawable starter out, engineer went to do some testing with a test lead, very thin wire. And the purpose was to test 24 volt signals. Unfortunately, he ended up to test, or not to test really, he ended up to put the test lead to the main voltage circuit, and the other end of the lead hit the door. And luckily he survived. There was arc flash protection installed, but the board was a little bit damaged because of the breaker delay. Couple of examples. There are a lot of these examples. Some of them are good, some of them are not that good stories. But here just some examples. Early 1980s, Ralph Lee wrote a paper, The Other Electrical Hazards, Electric Arc Blast Burns. And in that paper there was also this maximum power in three-phase arc in megawatts as an example. to imagine how much there can be arc fault energy. If the voltage fault is at some level, let's say 50 kiloamps, and depending what is the voltage level, for example in here 480 volts, the amount of energy is already 20 megawatts, which is a lot. And top left there is another curve. This is from 11 kV. We are talking more about low voltage today, but the pressure curve and the current curve and the timing curve is pretty much similar. The difference is more that when you have higher voltage, the arc flash can ignite easier, but the strong current is the thing which is burning the electrode, burning the ionized air and copper. So pressure and energy curve, just information and knowledge. Few low voltage applications. Again, low voltage, high current. Typical applications: main, which is one main incomer breaker. Main means one bus bar but two incomer breakers. Main tie main, same, but the tie breaker in between. And main tie main, which means that there is a main breaker, two main breakers, tie breaker, bus bar, and another tie breaker. And just an example, this main tie main, if it's this is more complex application, but if you think about AQ1000 arc quenching device, there should be arc quenching device. If it consider a complete board, there should be one AQ1000 in the left side, one in the middle between tie breakers, and one in the right side. Just an example. Typical industries: oil, paper, steel, car industry very much, marine, food industry, of course all the critical power, hospitals, data centers, etc. Underground, there are not many places where to remove all the exhaust gas, explosion gases, explosion pressure waves underground. So mining and subway networks, for example, are very good locations for this kind of quenching device. Today's topic was this AQ1000 arc quenching device, testing and commissioning. And reminder that AQ1000 belongs to well-known, well-proven AQ100 Arc Flash Protection series, Arc Flash Protection System. And it is part of it. Low voltage 690 volts, tested 200 kiloamps, operation time 2 milliseconds, mechanical operation time, closing time 2 milliseconds. Part of the AQ100 low voltage series, and sorry. Here on the table I have one of these relays. It is the top left relay AQ1000 PLV, which has a current and also point light sensors installed, and it is connected with the fiber to the arc quenching system, arc quenching device. Other relay types are fiber sensor units or point sensor units, different type, and also the rail mounted version. Just an example, main tie main application. Two main incomers, I think orange color. Orange color left and right, and then tiebreaker in between of those. So there is one arc quenching device on both sides. Test setup today. and test setup on site. There are few warnings. Of course, consider always safety first. Few warnings here, which is important. This unit here and all the units, AQ1000 units, are equipped with the counter. You can use this several times. This is already good to understand here. This is the only single shaft low voltage quencher in the world. This is also only reusable low voltage arc quenching in the market. So you can do the commissioning for this. You can do the commissioning 100 times. Mechanical closing can be done 100 times. But only if you are using commissioning input in here, one of these terminals here. And on site, many sites I have seen that, for example, this type of switch, operating switch, 0 to 1 switch, has been many times used to activate the commissioning input. If you do not activate that, the system automatically thinks always that this is the worst case scenario, and it only allows to use this unit twice. So good to remember, use the commissioning switch when you are doing commissioning. When you leave site, return the commissioning switch back to the service mode. Yeah, so commissioning switch. Other thing very important, before testing, it is important to test that there is no voltage in the bus bar. Commissioning switch, and then there is always a quite heavy handle with the unit. Arc quenching unit, it is recharged with this kind of handle, metal handle. After you have recharged the unit, remove this handle immediately. Do not leave the handle, just reload the unit. It will start then about 5 minutes charging. Remove the handle. Many switchgear manufacturers has been mounted this somehow inside the panel, for example cable compartment, and then this is available, or switch room, somewhere in switch room on the table or to the wall, for example. But important to remove the handle after recharging. So the device can be tested up to 100 times. And if we consider other units available, you cannot test. Typical arc quenching unit cannot be tested. It can be installed, it can be left, but it cannot be tested completely. This single shaft means also here, only single shaft in the world, means that all 3 phases are identical timing. They are closing identically same time, which makes the short circuit more pure. And also reminder, if you don't know what was the idea of this arc quenching unit, it is the idea that if there is arc fault anywhere in the system, anywhere in the board, the arc fault gets energy through the incomer, which is feeding the arc fault, and this unit is typically mounted very close to main incomer circuit breaker. And when the fault is burning, for example there, this unit close to the circuit breaker, and this unit relay and point sensor or fiber sensor will react extremely fast, and this unit will close 3 phases simultaneously. So the possible 100 kiloamp fault over there will transfer to here. And when it transfers, the fault is gone from the actual fault place, and this will hold up to 100 kiloamps for a certain amount of time. And during that time, we are also tripping the circuit breaker, which is feeding the fault. And in the end, this all happens in less than 4 milliseconds. And that's very fast. Okay, few reminders. Many times said probably already, but switch port has to be testing ready. No voltage. Set AQ1000 to commissioning mode, commissioning switch or similar. AQ1000 has to be mechanically installed properly. It has to be inspected and approved. Verification has to be done that yeah, this is properly installed. Bus bars are connected properly. There are correct insulation levels and so on. And after fiber optics is connected to the relay, press the set button for 3 seconds from here, and from the relay itself it will start auto-configurating, and after auto-configurating everything is ready and done. What do you need for the testing? Any type of testing kit which can inject 3-phase current to the unit here. Yeah, so this can also work as a light only, but if the double criteria like a current and light is selected, then you need also to have this, you need also some kind of testing kit for the 3-phase current. Can be also set up with the 1-phase testing kit. It doesn't really matter. You can test 3 phases separately or 1 phase at a time. It is also okay. Flash. I use, for example, I use this kind of a camera flash, professional camera flash. There are different types of flash, but this can be used also together with test kit. Strong enough and very simple to use. This one is a brand name Nissin DI622. Okay, so we have the current here, we have the flash here. We can with the test kit, we can activate this one. We can measure the closing time if necessary, not always necessary. But if it's necessary, we can use the test kit also for measuring the closing time. No notification, every device, every AQ1000 has been factory time tested before entering site. Other testings which may be necessary, for example, multimeter, maybe insulation resistance measurements, maybe dielectric testing. All these insulation resistance, dielectric, when AQ1000 is opened. And bus bar low impedance after unit is closed. During testing, you can test, for example, low impedance from the bus bar wherever it is a good location for the test. Just to test that the resistance is zero, practically zero. Safety first. Follow the safety rules, standards, instructions during test. Always safety first. And many times switch port has to be testing ready, no voltage. when we are closing this, it will make the short circuit. So if there's a voltage on the board, this can handle the voltage, but it is not the purpose. The purpose is that the switchboard is of course testing ready. Test kit, inject current over threshold level. You can set the thresholds from the relay. Start flashlight with timer if necessary, or just manually like I'm going to do next. Record circuit breaker tripping time. If customer wants to know better timing, it is of course possible. It is possible to measure low impedance state. It is possible to measure circuit breaker opening time. And record busbar low impedance and time from the most suitable location and safe location, of course. And here example, just a short example that let's consider this main time main case. During the test, of course, important to test that the correct AQD device is closing. So if we have fault on here left side, we shouldn't activate, in this case we should not activate the right hand side quenching device, but we should trip and activate the left side quenching device, and then the fault disappears where the fault started. Installation guidelines. Door mounted, flush mounted relays. First, relays and the full system. AQ1000 is part of the system, but of course you need to have the relays, point sensor, fiber sensors, whatever is designed and engineered into your system. Then flush mounting for the relays, deep switch engineering, and all the settings, fibers to the AQD, and then set button 3 seconds, set button 3 seconds. Because the system is very simple to use, after engineering drawings has been done properly, then it is very easy just to push button and the system is ready to go. Installations mainly horizontally, but this unit can also be installed vertically. For example, to the behind the doors, which are more narrow in space. And busbar installation according low voltage standards and local standards, what is used in your country. Busbars can be mounted in many possible directions, and here are 2 examples how to do the correct bolting to the system. Here is one example from the low voltage board. AQ1000 is installed here in the bottom left under the circuit breaker. On top left there is a bus bars, what comes from the transformer. It goes to the circuit breaker, and under the circuit breaker the bus bars goes to the horizontal and vertical bus bars inside the panel. So most typical installation plays as close AQ1000 as close the main circuit breaker as possible, as technically possible. For the new builds it is almost always possible. For the retrofits you may have to consider also other locations, but as close as technically possible. And here, if there's a fault anywhere in the board, feeder, anywhere after the circuit breaker, if there's arc flash, then this arc quenching unit will close in less than 4 milliseconds, and the circuit breaker starts to open simultaneously. And that takes typically 30 to even 150 milliseconds. 150 milliseconds, it is about blink of an eye. Door mounting, point sensor installation, possible fiber installation and wiring, and AQ1000 installation. And the top right corner you can see the commissioning switch, and this is a commissioning switch which is also equipped with the padlock. So when commissioning engineer leaves site, they will close this commissioning switch with the padlock, and then the unit is in a ready state, ready to action. Testing and commissioning. Push the button, 3 seconds, 3 seconds. Check no error lights. All the inputs are connected, all the dip switches are connected, thresholds are correct. Then test kit inject the current, flash with the camera flash or with the test kit flash. Close the enclosure and then change this commissioning switch position back to ready mode, then the job is done. Timing tests with oscillographs. Here, this is now a timing test. I just took this photo today from our production, and this is a timing test about the single shaft mechanical closing time. From the position, from the flash to the closed position, and the mechanical closing time for this particular device was 1.98 millisecond. So typically, yeah, we can say that the mechanical closing time is 2 milliseconds. Yes. And then I have another oscillographs. I will show it a bit later, but it is the total operation time from the flash. I have a special setup to record the exact flash time. So I will have that. Then I will have the connections from the busbar connections when the AQ1000 is closing. So that is then the full sequence from the flash itself to the mechanical closing, and that is then seen here. Total operation time, you can see that from the flash to the actual closing time, which is total clearing time of the fault also. Total clearing time, it is still extremely fast. And reminder, you can use it again. But now, this type of AQ01 sensor, I'm going to flash this type of sensor with this camera flash, and many times as quicker than blink of an eye, this device will close. So it will keep quite a lot of noise. Yeah, okay, I can also, I don't know how you can see this from camera, but I have this multimeter here, which kind of shows very high amount of mega ohms, because the unit is now open, and I will show, maybe you can see it. It's kind of maybe you can see it. If you don't, I will tell it in another way. But okay, just a moment. So this type of point sensor, this type of flash, and testing with the speed of light. Oh, that really is a loud voice. This is it. If you have any questions, you can contact Arcteq Sales, Arcteq Technical Support, myself. Yeah, this I will also so many things to say that all may forgot something, but this now shows 0.1 ohms, which is the most accurate what you can do with this type of multimeter. But practically we are talking about micro ohms. It's very pure single shaft movement, 3-phase closing simultaneously. So there are not practically any microseconds different. It's very accurate 3-phase short circuit. And when the short circuit is pure, then the voltage will drop quickly to very low level, close to zero or very pure. And then the current will transfer from the fault immediately to this unit, because it has only micro ohms. After the incomer circuit breaker, this has only micro ohms, very pure short circuit, and the fault transfers to this unit. Yes. Okay, if any questions, Arcteq Sales, Arcteq Technical Support, myself, and hope you enjoyed. Thank you.